my point of view from engineering, there are many things that I would get involved with. One example is the King's Cross development. Before all of these buildings were built, the ground was very soft, so it would absorb the rainfall. But what's happened now, you have these hard roof surfaces and road surfaces and pavements, and all that rain has to run off somewhere. And traditionally, it has run into the London sewers. But we're finding more and more that they're at capacity. Rainwater has to go somewhere. And so one solution has been to use the canal to take that water all the way down through 9 locks down to the River Thames. But to achieve that, we've had to do some clever design of extending the weirs at each lock. And the way we achieve that is by altering the weir crest shape to a zigzag, which essentially lengthens the weir. So it's like taking one long straight weir and squashing it into a smaller space. And it means then that more water can go over the weir, preventing the water levels from coming up as we take more rainfall in. And we can charge for accepting that rainfall. So that's been one of the engineering projects that I've been involved with, just been very interesting. You'll see here there are some old wooden gates. They're called air raid protection gates, and they were installed in the Second World War because there was a danger that a bomb could breach the canal and maybe open up one of the railway tunnels, and then all of the canal water would have emptied into the tunnels. So these gates are designed to snap shut in front of the water as it moves forward, preventing the canal from emptying into the breach or the hole. And so, although they're an important part of our heritage, they're expensive to maintain. And there's still a small risk that breaches can occur. And so we've had to come up with engineering design to produce a solution, a cost-effective solution. And what we've done is design some aluminium stop planks, which will be dropped into grooves either side of the canal in an emergency, and those planks will prevent the water from carrying on down through to the breach. But we've had to think about materials engineering it. It has to be a material that's light enough for our staff to manhandle into place, but it's also had to have the strength, which is the structural engineering, to make sure they don't buckle under the weight of the water pushing. Under the towpaths there are high voltage electricity cables and fibre optic cables. The towpaths offer a fantastic opportunity to provide a network across the country for these cables. But what people perhaps don't realise is that high voltage electricity cables get very hot and they need cooling. And right next to the cables we've got the cold canal water. And so what we do is use the canal water to cool the cables. And increasingly we're using canal water to cool buildings alongside the canal, so the water is incorporated in their air conditioning systems. But water that's taken out to cool must also be put back into the water at the same temperature. So engineers nowadays have to be environmentally conscious. So warm water can affect algae growth and plant growth and the fish that live in the canal. There is also another advantage of having warm cables under the towpath. It melts the snow and the ice, so in the winter our towpaths are safe to walk on.